Hello everybody who is watching this video. This is Sir Olenjolaim from United Republic of Tanzania. I would like to welcome you into these sessions that you are watching right now, and I would like just to invite you into this fantastic session of Archimedes principle today, that we are going to have the second session. So I've already told you in the first session concerning about the subtopics and the specific objective according to the physics syllabus for ordinary secondary school of United Republic of Tanzania for the Form 1 through the Form 4. But today our focus that will be focusing on lecture 2 or session 2 of Archimedes principle and law of flotation for the Form 1. So I would like just I left a homework for you of the 2 questions in the first lecture or in the first sessions. The first questions will say differentiate between the thrust and the upthrust and thrust. I've already told you before the notes. What is the directions of the buoyant force? Okay, explain briefly. Remember that buoyant force is equivalent or is another names of upthrust force. So that's what I've taught you. So join me in the second session. This is session 2 or period 2 or lecture 2. So we are still proceeding with upthrusting at the concept that we are still learning is called the upthrust. And if you have questions, please ask in the comment section. I would like just to thank you for watching the first lecture, and then so I would like to invite you in the second lecture. Okay, so the concepts of upthrust, and today we are going to have a focus on 3 concepts. Leo tunakwenda, as I said that leo tunakwenda kuangalia vipengele vitatu vya msingi kuhusiana na upthrust ili tuweze kumaliza na kufikia lengo la kwanza kuelewa nini maana ya upthrust kama mwanafunzi wa kidato cha kwanza. The first concept that I'm going to teach you is practical demonstrations of the concept of the upthrust. And the second concept that I will be teaching you is actually defining the terms partial immersed and totally or completely immersed. What does it mean? You heard those words when we are defining the concepts of the upthrust. So today I will be learning each terms, what does it mean, and by using diagrams we'll understand and make them a distinction for the rest of your life. Again, I will be teaching you another concept called that the weight or the apparent loss in weight of a body when it has been dropped into the fluid. Okay, so those are the 3 things in this second session or second lecture or second period. Nacho kwenye kipindi chetu cha siku ya leo cha pili cha Archimedes principle na law of flotation kama kinavyoonekana pale, nitaenda kufundisha concept 3 au vipengele vitatu vya msingi. Cha kwanza nitakuonyesha au nitakufundisha jinsi gani ambavyo upthrust naweza tukaifanya kivitendo. Alafu na cha pili nitakwenda kufundisha pia jinsi gani ambavyo tofauti ya maneno kwamba partially immersed na totally immersed. Maana yake kwamba kuzamishwa kwa kitu kuzamishwa kwa sehemu ya kitu ndani ya kimiminika au ndani ya gesi, na kuzamishwa kwa kitu kama kwa mfano jiwe unalizamisha lote katika kimiminika, kwa mfano maji. Kwa hicho ndio kipengele cha pili nitakachokwenda kufundisha, na kipengele cha 3 ambacho tutachukua cha mwisho kwamba majaribio yanaonyesha kama endapo kipima uzito wa kitu kikiwa katika hewa na ukipima uzito wa kitu kikiwa katika kimiminika, uzito wake unakuwa uko tofauti, na tutaona kadi ambavyo vitakavyokuwa. Kwa hicho kitendo kita apparent loss in weight. Kwa hiyo kuna kitendo au kuna hali ya kitu kupungua uzito wake kinapokuwa katika maji. Na ni kweli kabisa, kwa sababu nakumbuka nikiwa niko mdogo, nikiwa niko shule ya msingi, nilikuwa naishi maeneo ambayo kuna mito, na nilikuwa kwamba siwezi kulibeba dumu la lita 20 kwa umri wa kipindi kile, lakini naweza nitakapoambiwa kwamba nenda kachote mtoni, naweza nikaenda kuchota na nikajaza maji, alafu nikaweza kulivuta bila shida yoyote. Maana yake kwamba uzito wa kitu kwenye maji unakuwa unapungua na uzito wa kitu, ukifananisha na uzito wake katika hewa. Kwa hiyo ngoja nisimalize utamu wote, naomba tujiunge pamoja kama mwanafunzi unaopenda physics, na mimi nitajitahidi kadri nitakavyoweza kukufundisha physics na kukushawishi na kukufundisha na kukushauri na kukuelekeza kiasi ambacho kwamba physics inakuwa ni somo lako namba moja katika maisha yako ya sasa na baadaye. Kwa hiyo naomba twende pamoja. So today we are going to learn about demonstration, called it practical demonstration or experimental practical demonstration of upthrust. So I'll be teaching you in terms of steps. Nitakufundisha katika tiriko ambao ndo huwa namna hii. Kama ni 1. We say that consider a beaker if you are in laboratories, or if you are at home and you want to perform this experiment. You are not limited with the absence of the beaker at your home place. That is half filled. Okay, is half filled with water. So I will be using steps and then using diagrams to demonstrate the explanations of the steps. Nitakuwa natumia hatua mbalimbali na nitakuwa natumia mchoro kuonyesha pia jinsi gani ambavyo hii au maelezo yanamaanisha kitu gani. Kwa hiyo hiki ndio kikombe jagi lako, okay, ambalo ni inaweza kuwa transparent au sio transparent. So this is a beaker or a jug that is half filled with water. So this is water. So follow along please. Naomba tufuatane pamoja ili uweze kuelewa kitu nilichokiandaa siku ya leo kwa ajili ya wewe mwenye mapenzi makubwa sana na somo la physics. This is called the figure. Huu ni mchoro 5.1 ambayo nasema half filled beaker. We go for the second state. We say that take a piece of wood. So take a piece of wood. When you say a piece of wood, it's better if I specify dry wood. Chukua kipande cha mbao au mti wote ambao umekauka and drop it into the water. In a beaker or a jug. So chukua kipande hata kama ni fimbo kafu au a stick or a rod, and then this the what happens right now. You find that the space occupied by the water increases compared to previously. Utaona kama maji yameongezeka maji yameongezeka ujazo. Kwa hii ndio piece of wood. Kwa hii ndio naita a piece of dry wood. And then this one is called a beaker or a jug. So this is figure 5.3, mchoro namba 5.3, ambaye tunasema kwamba a jug or a beaker with a dry wood and water. Bika ikiwa ndani yake ina maji pamoja na kipande cha mti ambacho kilichokauka. So what do you observe there? Or what you can observe there? Okay? So this is the question. What do you observe? Unaona nini? Do you observe in figure 5.3? So you may observe that here we have two forces acting on the dry wood. Okay? So we say that there are two forces acting upon the dry wood. So observation, there are two forces acting in opposite direction. Okay, in opposite direction. Okay, in opposite directions, acting in opposite direction, acting to the body or to the dry wood, acting in opposite direction, perpendicular upon the dry wood. Kwa kuna kani mbili ambazo zina uwepo au zinatokea katika hiki kipande cha mti kilichokauka. So that suppose that this the beaker, this is a beaker. So suppose that here we have a beaker or a jug. If you are doing this experiment at your home, then your jug is partially filled with water. So you will realize that we say that according to the concepts of the Upthrust and even principles that will be stating that this liquid, or let me just introduce a dry wood first. So this is the piece of dry wood that is partially immersed in the liquid. So I can label it like this. Okay, so what happens? So remember that we say the liquid, or for this case is water, exert an upward force to a body that has been immersed. So that's the concept of upthrust. We say that it's an upward force that a liquid or a gas exerts on the body floating on it. So it means that this fluid is pushing the dry wood up. Okay? So this also fluid, this part of this fluid, and this is because of the pressure that I will be discussing later, but that's what happening. So all of these liquids will be pushing up what? This dry wood. So then we have two forces now. The first we call it W, which is weight of the dry wood, and the second force we call it is acting vertically, perpendicular vertically, we call it U. So whereby U stands for upthrust, and then that is U, and then W stands for weight of the body. So this is what you will observe. So it means that now if you have a dry wood itself here, and then we draw the forces. So this is weight of dry wood, and then this is what upthrust. So here I just showed the directions of the forces. It's not necessary for it to be a rod. It can be spherical, or it can be circular. It can be any shape. It can be a rough shape. For example, if it is a ball, then we find weight. Or if we drop a stone, for example, and then we have another force which is perpendicular, which we call the upthrust. So even if that will drop maybe rectangular body, so there are two forces that will be acting. So the first force, this is weight of a body, and then again we have an upward force, which we call it in physics upthrust. Okay, so remember that all these forces are perpendicular to the surface of the body. So are perpendicular to the surface of the body. Both forces are perpendicular to the surface of the body. None of the force which is parallel or maybe diagonal. Okay, so these are the different shapes. So we can say that suppose that this is figure 5.20. This is figure 5.20. Sorry, this is not 0.1. This is 0.2. This is 0.3. This is figure 5.24. A, B, and D, C. What did I represent there? We say that representation of the forces acting on a body, force ambazo zinazotokea kwenye kitu ambacho a body which has been kilichozamishwa dropped in the fluid. So that means of all these structures. So here, suppose that this is figure A, this is figure B, this is figure C. So don't be limited that maybe this happens only to the rod structure. It can be a rectangle, it can be a circular, it can be spherical bodies, it can be, even sometimes it can be just like in form of cylindrical or a cylinder and so forth. Okay, so that's what you observe. So it means that again, these two forces are very important, because if the two forces balances, then you can find that maybe a body is floating. If maybe the weight of the body is greater than the upthrust force, then the body is going to sink. Okay, so that's very important concept. That's why that I've been discussing about these two forces. Weight of the body is measured by using a spring balance. I think that you remember in the first chapter I've taught you. Okay, if you are in physics lab, so then this is a pin, this is number 2. Okay, and then let us continue with number 3. Observation. We say that if you are in physics lab, or you can go to your physics lab, right? If you are in physics lab, you can measure the weight of the dry wood, okay, in air, and call it weight 2, weight 1, okay, weight 1. Then we go for number 4. Again, you can use a spring balance. The spring balance and piece of string to tie means that to measure, to tie, and measure the weight of a dry wood in water. So weight of dry wood in water, and hence this we measure the weight of the dry wood in air. So here weight of the dry wood in water, and quality weight 2. Okay, so we can use a spring balance as a device that used to measure weight of objects in physics, to measure the weight of the dry wood in air. When you say that dry wood, suppose that this is the dry wood, so you can measure the weight of this dry wood in air before we drop it into water. Tunaweza tukapima uzito wa, maana kwamba uzito wa hii rula ikiwa bado haijazamishwa katika maji, ndio tunaita weight of a body in air. So here we are using a dry wood, maana kwamba kipande cha mti mkavu. Again, we can use a string, a piece of string, say string. String manake ni uzi. Tunaweza tukachukua uzi tukafunga hapa, tukafunga kwa mfano hapa kwenye hili tundu, tukafunga hapa, alafu upande mwingine wa string tukafunga kwenye spring balance. Na baada ya kufunga katika spring balance, kinachokuja kutokea ni kwamba tunaweza tukapima. Manake tunachosema hapa, demonstration yake inakuwa hivi. Okay? Inakuwa hivi kwamba hapa we have 3 figures. For example, this is the spring balance. This is the spring balance. Okay, this is the spring balance. This is the spring balance that we use in physics. So this is the spring balance that we use to measure the weight of the dry wood in air. Okay, so this is the point where we can suspend it, and then here we have a scale. Here we have a circular shape. So here we have a ruler or a piece of dry wood. Then suppose that this is weight 1. So this is dry wood. And this is spring balance. Spring balance. And this is figure 5.25. Again, we can have our spring balance here. Spring balance. We have our spring balance like this. Okay. Then this is the point. And here we have a rod, piece of dry wood. It has been dipped in a beaker. Remember that you enjoy the beauty of physics when you learn by using diagrams. Okay, because diagrams represent the experimental activity. Here we have weight 2. So this is figure 5.5b. So you see in this experiment that this is what I've explained in the third romance. If you are in physics lab, you can measure the weight of the dry wood in air and call it the weight 1, W1. This is what you have here. So this is the dry woods, and then we measure it in air. Okay? So then we go for the second experiment. So we say again, you can use a spring balance and a piece of string. This is the piece of string, right? A piece of string, okay, to tie and measure the weight of the dry woods in water and call it W2. So this is water as which is representing the fluid. So now the question is, with the question that I want to challenge you, the question that I would like just to ask you and take a few minutes to think about it is, what do you expect? Compare the weight of a dry wood in air and the weight of a dry wood in water. Fananisha uzito wa, so that is Roman 5, compare the weight of a dry wood in air and in water. In fluids is weight 1 greater than weight 2, or vice versa is true. Je, uzito wa kwanza utakuwa mkubwa kuliko uzito wa pili? And if yes, if the answer is yes, na kama jibu ndio, why? Why? Kwa nini? Nini kimetokea? Mbona tuna kipande kile cha mti hapa na tuna kipande kile cha mti kwenye maji? Nini kimetokea kama uzito huu ni mkubwa kuliko uzito huu? Kwa sababu tunachotarajia, if there nothing happens, tunachotarajia ni kwamba uzito wa kipisi cha au kipande cha mti mkavu kikiwa kwenye hewa kitakuwa na uzito sawa na kipande cha mti mkavu kikiwa kwenye maji. Okay? Au uzito wa jiwe tukipima katika hewa utakuwa ni sawa na uzito wa jiwe tukipima katika maji. Hayo ndio matarajio, lakini kinachotokea kwenye kesi kama hii si kweli. Kinachokuja kuonekana au kinachotokea ni kwamba uzito wa kitu kwenye hewa ni mkubwa kuliko uzito wa kitu kwenye maji. Manake kuna kupungua kwa uzito. Okay? Kwa kuna kupungua kwa uzito unapozamisha kitu. Kwa sema results, the weight of a dry wood in air, which you call W1, is greater than the weight of a dry wood in water. So simply say that weight 1 is greater than weight 2. So we still have. So I have helped you to answer the question of comparisons. So now I would like just to give you a quiz. Why weight 1 is greater than weight 2. What do you think are the physicists? What the cause? What happened there? We still have the same weight, we still have the same size, we still have the same shape of the dry wood when we measured its weight in air, and also when we measured its weight in water. We didn't change anything about the dry wood. We didn't even just take a hammer and try to change it. Possibly, don't get confused about maybe the size according to what I've drawn. This is just a handy drawing. So get in your mind that we take this ruler, we measure its weight in air, and then we take the way it is, we measure its weight in liquid. Example, water. That's the concept. Or we take this piece of chalk and measure its weight in air, and then we take the way it is. We don't reduce any part. We don't break it down. We don't reduce even small portions of it. And then we drop in water and measure its weight. So experiments show that the weight of this piece of chalk in air is greater than the weight of this chalk in water. Majaribio yanaonyesha kwamba nikichukua kipande hiki cha chaki nikapima uzito wake katika hewa, na nikachukua kipande hiki cha chaki pasipo kupunguza kitu sehemu yoyote, na pasipo kupunguza, pasipo kutumia tena au kuivunja kuifanya kitu chochote, nikapima uzito wake kwenye maji. Majaribio yanaonyesha kwamba uzito wa hiki kitu kwenye hewa ni mkubwa kuliko uzito wa hiki kitu nikikitumbukiza katika maji. Kiwe kimezama nusu, kiwe kimezama robo au nusu au 1/3 au 2/3 au robo tatu, au kimezama chote. Majaribio yanaonyesha kwamba uzito wa hiki kitu ni mdogo kwenye maji kuliko uzito wa hiki kitu kwenye hewa. Sasa swali ninalokuwa nakupa ulifikirie wakati tunavyoendelea kufundisha, nini kinachosababisha hicho kitu kiweze kutokea, wakati ukubwa na uzito na kila aina ya sifa ya hiki kipande cha chaki hakijabadilishwa. Kwa hiyo endelea kufikiria, alafu tanipa majibu baadaye. Okay? So you go for Roman 6. We say regardless. Okay? Regardless that the body, regardless that the body is totally or partially immersed in the fluid. For instance, water. Its weight will be reduced. Temporarily. Not permanently, temporary. Why temporary? Why temporary? Because for example, if we take this piece of chalk and then measure its weight in air, and then we take this piece of chalk and drop it in water, and then we take this piece of chalk again from water and we measure its weight in air, we find that the weight of this piece of chalk before I drop in water is equal to the weight of this piece of chalk after I immerse it in water and take it out and measure its weight in air. What does it mean? Suppose that the weight W1 is the weight of the dry wood in air before it has been dropped in water. And then this W2 is the weight of the dry wood after dropping it in water. And then suppose W3 is the weight of dry wood after you take it out of water. So experiments show that weight 1 is equal to weight 3. But remember that weight 1 is less than weight 3. And also, it's greater than weight 3. And also weight 2 or we say that weight 1 is less than, weight 1 is equal to weight 3. Weight 1 is greater than weight 2. Then weight 3 also is greater than weight 2. So remember this, this is a very important concept. Okay? So the weight of a body, whether before it has been dropped in fluid or after it has been dropped in fluid, is the same. So that's why we say that this piece of chalk or a dry wood that we've been using in this experiment, in these demonstrations, loses its weight temporarily, not permanently. Because if it's permanently, then we say that if it is permanently, we say that it means that weight 3 should be also less than weight 1, right? So that's your mind. So that bear that in your mind. So regardless of that, ones mean that the weight of the body, its weight. So make correction. Its weight, uzito wake unapungua kwa muda mfupi, sio kwa kudumu. Okay. So it means that suppose that weight of a body in air is W2 and then W1, and hence we say that weight of a body in water is W2, and then weight of a body taken from water to be weight 3. So if you compare, then you get these results. This is what you will find. Okay? So that's the concept that I wanted you to understand. Again, from lecture 1 or from the first session of Archimedes' principle law of rotation, you had 2 new vocabularies in your mind or in your life of physics, which actually are very relevant for you to understand them. So these 2 terms are the word totally immersed and the partially immersed. What does it mean when you hear the word partially immersed or totally immersed? So that's what I want to discuss before we come back to your quiz. What does it cause for weight 1, for the weight of the body in air to be greater than the weight of the body in what? In fluid. So let us discuss partially immiscible. What the meanings of this word? Partially immersed in a fluid or liquid. Okay? So here we have a question. I think that this is question number 4 or number 3. Okay? Sequence. What is the meaning? What is the meaning of a body to be partially immersed in a fluid? What does it mean? What do you mean in physics when you say this sentence? Okay? It means that ina maana kwamba hii ni maana ya kitu kuzamishwa nusu. It means that the body, hicho kitu, the body is immersed. Hicho kitu kimezamishwa. Immersed maana yake ni kimezamishwa. Immersed. Okay? Immersed in the fluid When you say fluid, we mean gas or liquid, such as water, the simplest fluid, such as water, that every student is familiar with it, and the body does not immerse, or doesn't immerse completely in the fluid, such as water or gas. Are the meanings of partially immersed in a fluid. The meaning of partially immersed in a fluid, we say that this is the tendency when a body has been taken, or when we physicists, we take a body and immerse it in the fluid, and such as water, such as honey, such as milk. We have different liquids actually, or even we want to dip it in oxygen or in carbon dioxide, and the body does not immerse completely in the fluid. Manake kwamba ni hiki partially immersed ni kitu tunapokitumbukiza katika kimiminika au katika gesi hakizami chote, kinazama sehemu. Okay? Kwa hiyo ndio point ambayo ya msingi. Manake for example, for instance, that if you want to use a diagram to demonstrate this concept, and this happens because, for example, you know the ships used to experience partially immersed in the lake or in the ocean. Okay? So suppose that this is the beaker or a basin or a bucket of water, right? And then you have a spherical body, or maybe you have a circular body, or you have different structure. It may be, okay, suppose that rectangular body like this, and then it is partially immersed. Partially immersed. So this is a tendency of partially immersed. So we say that this is figure 5.6, partially immersed in a fluid, or a body that is partially immersed in a fluid. That's what you mean. A body that partially immersed in a fluid. So this is a body, and then this is water, and this is, let's say, beaker or water container, etc. So that's the representations and the meanings of partially immersed. So from today onwards, when you hear the word partially immersed, have the mindset that the body is not completely immersed in the fluid or in the gas. And a good example of partially immersed is a boat, or a boat. Yes, a boat in a lake. So example of a body, we call it that is partially immersed, okay, in water, or yes, in water, such as ocean or lake, is ship, and then you have boat, okay, boat. Also you have dry wood, etc., etc., etc. So the second terminology is completely, what the meanings of a body to be completely or totally, completely or totally immersed. Okay? because we'll be using this word immersed in the fluid. We'll be using this word often. So I want to define them, so whenever you encounter them or you find them in the sentence, you know what does it mean. Haya maneno nitayatumia sana katika topic hii. Kwa napenda kuyatafsiri ili utakapokuwa unakutana nayo basi uweze kuyaelewa vizuri. Question 4. What is the meaning? Nini maana of the body to be completely immersed in the fluid? Okay, so let me answer this question, and then I'll come back to your quiz. Why the weight of the body in air is greater than the weight of the body in a liquid or in the fluid? Why? So that's the quiz. Keep on brainstorming. Remember the material that you covered during your primary school. And then don't tell me that because of Archimedes' principle. No. Give me the reasons and evidence. The meaning, it means that the body is completely immersed in the fluid after it has been